In this video, we're going to learn how to select objects in your game. And we're going to do that by accessing the camera's transform, so your two-dimensional camera's transforms. And in addition, we're going to put some scripts onto some game objects to determine if you are hovering over that particular object. This is common in games where you might hover over an object and it highlights or it performs some sort of animation. And you can do the same thing with this method. Now, the way that we're going to do this is first by adding a script to the main camera. Now, in Unity, whenever you create a new scene, it's going to just create a generic camera according to your project preferences. So in this project, it's 2D. So if I look at my camera here, what I'll see is that it's an orthographic camera. And what this means is that there's no foreshortening of lines for perspective. And, it has some sort of default settings on it. Now, the main camera is a game object like any other game object. So I can add scripts to it. And I'm going to do that here simply by creating a new script inside this folder. And I'm going to call this something like mouse world pause for position. So I don't have to type so much. And then I'm just going to take it and I'm going to attach it by dragging it over to my object here onto this world, onto this camera. Then I'll go ahead and launch my Visual Studio here. Now what I want to do is I want to be able to expose what the current world coordinates of the mouse position are. Now the mouse is really in something that we call screen coordinates. And the screen coordinates are, basically pixels that the operating system gives us for where the mouse is located. And what we want to do is turn those into world coordinates. Now, it's a little bit weird because our camera is actually a three-dimensional camera. And when we do the transform of the mouse positions in screen coordinates, we're going to end up with a world coordinate that's somewhere in three-dimensional space. So we're going to have to deal with that. But let's just start simply by showing what that point is. So I'm going to say vector 3, and I will call this something like mouse world position. And what I want to do is now in my update, I'm going to grab the screen position of the mouse and turn it into world coordinates. So I'm going to do that by first grabbing the camera. And the camera is a component inside this game object. So I have to say get component camera. Let's give ourselves a little comment. Then we're going to, use the camera's transform to convert a screen point to a world point. And let's just call this world PT for short, and we'll say camera dot screen to world point. So as you can see, this is a function that's on the camera object, and it does that transform. So it uses its basically like an inverse transform in order to get a screen point and convert it into a world point. So we will then create a new vector, and this is going to be based on, we're going to take input and we can get the mouse position, X, and then the input mouse position, Y. And we might as well get the input mouse position, Z, even though that's not really clear what that's going to be, especially when we're dealing with a, most mice are 2D. And I also forgot to declare what type this was. So let's make this a vector 3 here. This will give us the world point. And because the camera is located at some position in space, we're going to, see that this transform is going to be relative to wherever the camera is located. And the real issue is really the Z position here. So the Z position, it's kind of questionable as to what's going to come out. So actually what I'm going to do is I'm going to take a look. Let's see what the world point looks like. And we will just call this world point. So I have to do so much retyping here. And now we'll just assign that, and then we can see it in our actual game object. So then what we want to do is store the mouse world position and we're going to say it is a new vector 3 that is based on the world point x, world point y, and then 0. And then this is going to give us something that's on the 0 plane, which presumably is somewhere around where our objects are located, but they may or may not be, depending on if you move them slightly in order to make some draw in front of the other, or if you're using layering or things like that. So all we know is that whatever this z coordinate is, we're going to have to take care of it at some point to find out exactly what's going on with it, and that it has the correct values in it. Otherwise, our intersection tests don't work because the z coordinate could be way in front of or behind of the object. So let's go back to our game now, and not much of a game, but we can hit play. And we'll see down here that we have these, the mouse world position and the world point, and we have an x, y, and it looks like the world point, the z coordinate was probably 0 that the mouse was giving us, and so this is now at the -10 location, which is actually where our camera is. You might be wondering how I know. Well, look at the position of this transform, it's at -10. So so if you immediately just took that point and tried to intersect it with some object in your scene, you wouldn't be able to intersect if you checked using the z coordinate.